Imagine staring deep into the universe and suddenly realizing it's staring back at you. That's exactly what scientists felt when the James Webb Space Telescope, the most powerful eye ever launched into space, detected something completely unexpected. This wasn't just another distant galaxy or a pretty nebula to add to NASA's image gallery. This was a set of signals, patterns, and anomalies that broke every rule we thought we understood about the cosmos. At first glance, it all seemed random, but the deeper they looked, the more it began to feel deliberate, structured, even intelligent. For decades, we believed the universe was indifferent to our existence, a cold, endless void ruled by physics and chance. But what if we were wrong all along? What if, hidden in the silence of deep space, there are messages waiting to be discovered? Messages we were never meant to see? Today, we dive into the latest data from the James Webb Space Telescope. Data so shocking, so unprecedented, that some astronomers are beginning to ask the unthinkable. Are we finally seeing proof that we're not alone? It all began with an unexpected anomaly, right here in our own cosmic backyard. James Webb was pointed at Neptune, one of the ice giants on the edge of our solar system. A planet so far and so cold, it feels frozen in both time and space. But Webb saw something that shook decades of scientific understanding. Compared to data collected by Voyager 2 in 1989 and recent Earth-based telescopes, Neptune's upper atmosphere had dropped in temperature, dramatically. Not over millennia or centuries, but in just the last few decades. And the readings were clear. Parts of the atmosphere had cooled by nearly 10 degrees Celsius, and no one knew why. Solar cycles didn't explain it. Internal heat variations didn't either. And here's the chilling part. Webb also picked up strange shifts in Neptune's magnetosphere. Subtle, but real, like a silent heartbeat from a planet we never knew had one. Was an outside force influencing Neptune? A passing gravitational wave? A shift in dark matter density? Or something even stranger? Something that affects entire planets? Quietly, across impossible distances. The data opened the first door, and behind it wasn't just ice. It was mystery. While Neptune's anomaly raised eyebrows, what James Webb found in the TRAPPIST-1 system made scientists rethink everything they knew about exoplanets. TRAPPIST-1, just 39 light-years away, already made headlines for hosting 7 rocky planets, 3 of which orbit within the system's habitable zone. But Webb didn't just confirm they were worth studying. It revealed something far deeper. Using infrared spectroscopy, Webb detected the unmistakable spectral fingerprints of water vapor in the atmospheres of at least 2 planets, TRAPPIST-1d and 1e. And not just a trace. The data pointed to dense, humid atmospheres, possibly with cloud systems like Earth's. Combined with orbital patterns and temperature profiles, scientists now believe the most likely explanation is global oceans, deep, stable, ancient. Even more astonishing, Webb detected ozone-like compounds, molecular markers that, on Earth, are linked to biological processes. It's not proof of life, but it's the closest we've ever come to finding the right conditions for it. Not once, but twice. 2 planets, 1 star system. Just imagine. A miniature solar system with multiple Earth-like worlds quietly circling in the dark. And now, Webb shows us they're more than targets. They're real, vibrant, and maybe alive. While those nearby revelations were already mind-blowing, James Webb had its gaze fixed on something far older. In one of its deepest surveys, it captured light from a galaxy known as JADES GSZ 130, one of the oldest galaxies ever observed, formed just 330 million years after the Big Bang. But it wasn't just the galaxy's age that shocked scientists. It was the Lyman alpha radiation it emitted, a frequency normally absorbed by clouds of neutral hydrogen in the early universe. Yet this signal was far too strong, far too clear, as if that hydrogen had already been ionized, allowing the light to travel freely. This completely flips what we thought we knew about the epoch of rionization, the time when the universe transitioned from darkness to light. If this galaxy emitted that radiation at such an early time, then something may have triggered the transition much earlier than expected. Was it a natural anomaly, or the early fingerprints of galactic engineering? An unknown energy process setting the cosmos alight before it was ready? The implications are staggering. It's no longer just about what happened. It's about why and who, if anyone, was there to make it happen. Webb then turned toward white dwarfs, dead stars. Scientists expected to find only debris, silence, and ruins. But Webb found something that shouldn't exist. In the system WD 1856 plus 534, it detected a giant gas planet orbiting just a few million kilometers from the dead star. That shouldn't be possible. The death of a star into a white dwarf usually destroys anything nearby. But this planet not only survived, it adapted. What shocked scientists even more were the chemicals in its atmosphere: vaporized water, sulfur compounds, and indicators of atmospheric regeneration. Somehow, this planet had recovered from its star's death. And that changes everything. We've always believed life can only exist around living stars. But what if there are civilizations or ecosystems that evolve to live in fading light, using alternative energy sources? Suddenly, white dwarfs, once thought to mark the end of life, might be the best place to look for intelligent life that survives cosmic extinction. While Webb explored the deep cosmos, it also looked at the hidden corners of our own solar system, specifically the outer moons of Uranus and Neptune. Small, cold rocks we thought were dead and useless. But Webb's data told a different story. Infrared mapping revealed heat signatures on tiny moons like Hippocamp and Despina that shouldn't have any internal activity. Yet they glowed with unexpected warmth, suggesting cryovolcanism or geological activity beneath their icy surfaces. Even more puzzling? Webb detected complex carbon compounds, potential organic building blocks, on their surfaces. But how could such small, frozen moons, so far from the Sun, maintain internal energy for billions of years? Some propose radioactive decay. Others suggest tidal heating. But neither explains the organization of the compounds found. Which leads to a third theory: external seeding. Did something deliver these compounds? Are these moons ancient relics of something older? And then, Webb captured something truly unexpected from a familiar galaxy: Messier 82, aka the Cigar Galaxy. Already known for its explosive star formation, scientists thought they'd seen it all there. But Webb picked up a repeating infrared pulse coming from its core. Not random, not noise. A beacon. The signal had structure, rhythm, mathematical spacing. Its pattern closely resembled artificial modulation. Privately, some scientists are already comparing it to early SETI signal templates used to search for alien transmissions. Could it be a pulsar or some extreme natural event? Maybe. But there's no matching X-ray or visible light signature, which opens up an eerie possibility. What if this is the fading trail of a long-dead transmission? Not meant for us, but something we intercepted by accident. Do you remember Tabby's star, or KIC 846, 2852? The one whose light flickered strangely, sparking talk of alien megastructures. Webb took a deeper look. And instead of solving the mystery, it made it even stranger. It wasn't dust or comets. It was thin, opaque objects, passing in front of the star in perfect intervals. Objects that were flat, geometric, and possibly massive. They blocked light in a way that didn't make sense. as if layers or swarms of structures were orbiting. Webb also picked up waste heat in the region, a steady infrared glow that didn't match the star's natural output, almost like something is collecting energy and radiating the leftovers. The term Dyson swarm is being whispered again, not as science fiction, but as a genuine possibility. And then came Pandora's cluster, a gravitational lens revealing galaxies from the dawn of time. But this time, shadows moved across background galaxies. Not once, multiple times. Real occultations, not glitches. Yet nothing visible cast the shadows. Whatever passed through that lens didn't emit or reflect light. It was only detected by what it blocked. Webb's team believes these may be massive, dark, stealth objects, possibly non-reflective megastructures or hidden technologies. This isn't just missing matter. It's something organized, engineered, and invisible by design. What James Webb is revealing isn't just beauty, science, or wonder. It's something deeper, something almost forbidden. A series of clues scattered across space and time, each one pushing the limits of our understanding, all whispering the same silent question. What if the universe was never empty? What if we've been watched all along? From Neptune's frozen moons to structured pulses in distant galaxies. From oceans on TRAPPIST planets to dark silhouettes moving behind cosmic curtains. Webb hasn't just opened a new eye on the cosmos. It's pulled back the veil, a veil we never knew existed, one that may have been put there for a reason. And now, there's no turning back. We're standing on the edge of a discovery that could redefine humanity itself. A realization that the universe isn't just vast. It may be conscious, watching, responding, or warning. But here's the truth. This is just the beginning. If this video sparked something in you, if you felt that chill, that eerie sense that something big is coming, don't stop here. Subscribe now so you don't miss what the James Webb Space Telescope finds next. And tell us below, what do you think is out there?